What's up, everybody? Welcome back. Today we are working on our collaborative Rube Goldberg machine, and today's topic is trying to eat some dog food. So, the idea here is that we're trying to get to the point where we are ready to deploy this thing, right? So we're getting pretty close. Here's like an example. We have these chambers, they're run by WASM modules. Each module is like completely independent of the simulation, in that like the simulation as a whole doesn't know anything in particular about these modules. They are just there, right? So people can upload chambers by kind of going in here, and they can say like, hey, I have this here, maybe we'll show like, so here I can like upload our counter chamber, for example, right? And here's like a little preview of it, and we can like adjust the physics, whatever, adjust the number of balls, and this is like all client side. So this is how I would like start testing this thing if I was doing like initial development. Then when I'm like happy with this thing, I go to this upload view, I type in like, here is which what we're calling, which one we're looking at, counter. So we're like, here, I have a counter module and I would like to submit it, please. And we go to this user page and it says, hey, we're pending validation right now. Eventually, our server passes validation and we're validated now. And me as an admin, I can go in here and I can say, okay, so this guy, testing admin, me, has submitted this module and I would like to accept it now. And we accept it. And once we accept it, it goes into the main simulation. We see it in the bottom left here. What I want to do today is I want to work through that workflow for a couple new modules, make sure that like documentation, maybe like the capabilities of our APIs. I want to make sure that like everything is kind of in like a good spot, so that if we were to deploy that, if we were to go live and say, okay, people, everybody, you can now start uploading modules to like the instance at spherophoria.dev. We want to make sure that it's not going, we're not going to break everyone's chambers if they were to start uploading. So we need to make sure like our API is stable, and we also want to make sure that like the capabilities of the modules are like correct. So there's a couple chambers that I want to implement that will make sure that we have capabilities that we need. One is I want to implement like a little pong chamber. So just something like maybe the ball like comes into the chamber and he flies in here and it becomes like zero gravity in here. And we have like a paddle on the right and a paddle on the left, and both of these paddles are like basically trying to track the ball. Right, so it'll see a ball come in here, and it's gonna like move over here, and we're gonna try to move the paddle down to match it. And we'll probably cap the speed of this thing because we need to make sure that it misses. And then maybe we'll show a little scorecard up here, right? Like over time, how many of these guys have like where have more balls gone out? Have they gone out the left? Have they gone out the right? And so this will make sure that we have like zero gravity as like a concept that we can implement, which will open up a lot of chamber possibilities, right? Like if we wanted to do something that's like a pool of water where balls will like kind of like float buoyantly, have buoyancy, right? That like being able to fuck with gravity will like allow this type of behavior. And then the other one I wanted to implement was like some sort of like Pac-Man thing. So maybe like there's like with gravity, the balls maybe like follow these like paths, right? That maybe like we have a little Pac-Man guy walking around in, right? And for Pac-Man to be able to eat a ball, he has to be able to like, first of all, like the ball needs to be covered by Pac-Man. Right now we only do rendering behind the balls. We need to make sure that we do rendering in front of the balls to do that. And then also we need to have like somewhere where the balls go when he eats them. So he's gonna eat them and like send them out here, and then maybe they fall out the chamber or something. Don't know. Haven't really thought too far about it. And then like we have like we could do like a brick breaker one or something just to get a little further. But I imagine that this will take enough time. Imagine this will take enough time. Hey, do you also want the ability to move and order the location of chambers in the simulation view? Yeah, but I think that I can do that after. I want to kind of get to the point where people can submit as soon as possible. So I think that I can do like kind of like camera tracking and ordering of these things and stuff. I can kind of do that after. That's kind of the idea. That's the idea. Okay, let's start with a pong chamber. Let's start with pong. So the first thing that we need to do here is find some way to counteract gravity, which we don't really have right now because in our simulation, we kind of unconditionally apply gravity on every step. And I think all I want to do here is I just want to say, fuck it, we're not going to apply gravity. And that's up to the chamber to decide that they want the balls to fall downwards. Now, that's a little bit unideal, non-ideal, because we want to make sure that there's like, it would be nice if there's some sort of like consistent feeling between different chambers, right? Like right now, because the gravity is the same through all these, there is a feeling of consistency here, right? And so I think probably what I want to do is we have this physics library that we like recommend people use. Like it would be kind of hard to write a chamber without the physics library because like the definition of the ball and stuff is in there. So what we can do is we can just add like apply gravity as like a thing that people can call in there. And if they don't want to do that, then they can like opt out. Is what I was thinking. It's what I was thinking. It's saying things are already open, which makes me think I might have like two terminal or two Vim instances open somewhere. No? I don't know. Okay. Whatever. Oh, it just says there's a lock file that kind of is stale, so maybe just delete it. There we go. Perfect. Okay, so in here, let's just take where apply gravity and just shove it in here. And all apply, oh, this is the wrong file. All apply gravity has to do is add this constant. Add this constant to the ball velocity. Wow, how complicated. How complicated. And probably we want to just do this on like all balls. Maybe just on a ball at a time. I guess a ball at a time gives like the chamber writers more flexibility for like maybe there's a low gravity area in their thing. And if we said you can only apply gravity on contiguous sections, then that would be kind of limiting. They would have to like do some memory shuffling in order to use this. So maybe we'll just continue doing it on one ball. I think that's fine. I think that is fine. And we will go into our simulation here. We'll just kind of like nuke this apply gravity. And that should give us what we need. So now, probably if we compile this, probably all of our chambers now are just like totally fucked, which is kind of funny, right? Like if I refresh here, yeah, now just none of the balls are moving, which is pretty funny. So we need to fix these chambers to apply gravity now. So we have this like we have our physics library is like written in Zig, but we have some. We have like we expose these functions through like a C API. So we have like physics C bindings, and here we just kind of like basically copy paste the functions. It's like apply gravity, and it's gonna be a ball and a delta, I think is the parameters here. And here we're just gonna say physics apply gravity to the ball with the delta. And now we just have to expose this in our physics header as apply gravity. And we apply this to a ball with a delta. Now, what's kind of fun here is that we like have these like crazy assertions here that make sure that the types in these functions match the types in these functions. So hopefully this builds. Yo, why not offer both? I think that because I don't want to make I want to avoid making the APIs complex over anything, right? So you're right. I did consider the idea of like having in like, you know, here we could do something like pub export function like requires gravity, right? Or something, and then this guy like returns like a bool, and we return like true for most of them, right? That's like an option. One is like maybe there's like pub export function step no gravity, right? And like we can like choose to run this one instead of this one if it's present. But like kind of like I'd rather just force the developers of chambers to just apply the gravity to the ball, because like I think that any like API, I think like I prefer API complexity. Oh, I was thinking just apply gravity to balls as well. Oh, I see. Yeah, I guess we could do that. That's not nearly as bad. I kind of see that argument. But we'll see if I feel like I need it. Apply gravity, ball, delta. Right, like if would it be worth considering letting people set gravity in case they want to slow things down instead of just on off? Well, what I'm saying here is like they can choose to just apply different velocity, because all apply gravity is doing is he's just basically applying this acceleration, right? And if people want less gravity, like they can just choose their own constant. Really, the only reason that this function exists is to store this constant, and maybe like give a name to something that everyone's going to be doing, you know? So I don't think that like we need to really do that for everyone. Here, apply gravity. What were those other chambers? We had platforms. Here we also have to apply gravity. for each ball. And what else? What else? We have counter. So counter is written in Rust, and he's going to be using the C bindings to our physics library. And so this is going to look something like physics apply gravity to the ball with the delta. And this is unsafe, so fuck you. This goes here. And is ball here a reference? Yes, so this is fine. I wonder if we have to like manually cast this thing or if it will figure it out for us. I'm actually not sure. We can find out. It looks like it's fine, so we're chilling. And then we had Plinko, which needs gravity applied to it. So here we're gonna say apply gravity, also using the C bindings for the ball with the delta. And is that all of them? Let's see. Let's see. Oh, I think we missed dude. Yeah, dude's not doing it anymore. But the rest of them feel maybe okay. It's hard to tell if there's no balls getting to the platforms. Oh yeah, it's just dude that needs them. Okay. Dude.zig needs physics, apply, gravity, ball, delta. So I kind of figure that like the vast majority of chambers are going to be iterating over balls anyways. So I don't know if like we really need to give the arrayed version of this. So I'm not really too worried about it. I think it's fine doing it this way. Okay. Chill. 25 balls. Yeah, everything. Plinko actually looks like it's not applying. There's something wrong with Plinko. Huh? Something wrong with Plinko. What the fuck? That's very strange. It's possible that I fucked this up while I was doing some debugging earlier today. That's very possible. Source, chambers, Plinko. Like, so here, why does this diff look like this? This looks like, are these not the same fucking lines? Normal. Oh, sorry. This is diff origin master. That makes way more sense. No, okay, so no changes there. It's a little odd. It's definitely very odd. Zig build chambers. What the fuck is going on there? Oops, wrong button. Chamber testing. Plinko. Yeah, what the fuck? Oh, wait. It is hitting them. Oh, I'm an idiot. I'm an idiot. Aha. So, here we are applying gravity for every ball for every peg, which is just fucking stupid. We should double check that we didn't do it in all the other places. Platforms. So here we are iterating over platforms. Okay, never mind. Never mind. I do want... I think I actually do want the apply gravity... apply... I mean, we could also just invert the dependency order, but I think that we do want to iterate by platforms first so that we can like generate platform structures one time. Okay. That's fine. We'll just do this for now. We can maybe loop back for a better function, but for now we'll do it like this. Okay, so platforms. What else is in here? Platforms, simple. So this is fine. Simple is only iterating once. This one's fine. We had platforms, simple, dude. Dude is also iterating at the top level, so this is also probably fine. Dude, yes, Matt, dude. So we did simple, we did platforms, we did dude. There's counter. Counter is applying this again only one time, so we're chilling there. We had Plinko, which was our problem thing. So here we're just gonna make a second loop out here. So copy this loop like this, like this, like this. What do I do when I'm not streaming? Just more coding. We love coding. But you know, gotta walk my dog. I gotta play video games, hang with my friends. You know, just normal stuff. Just sit at the computer all day, every day. Which I feel like I'm missing a chamber. I need to look at them to see. We did this one, we did this one, we did this one, we did this one. Oh, spinny bar. We did not do spinny bar. So this has multiple surfaces, so this is gonna have the same fucking problem. So this has to get the loop pulled out as well. 4 balls, ball, apply gravity. There we go. Yeah, fuck it, we'll do here. Maybe here, maybe here. All right. It's hard to tell. Maybe we increase the number of balls just to make sure. This looks fine. This looks fine. Yeah, they all look fine now. I'm pretty sure. Pretty sure. Okay, cool. Cool. So maybe we'll kind of duplicate this and we'll say support 0 grav. And this is done. And now we are at 1645. And now we can actually start implementing a pong chamber. Okay. So maybe we get add-u here, actually. Maybe we run our linter to make sure that everything's formatted correctly, which it looks like it is. And we just make sure everything is good to go. Apply gravity, apply gravity, apply gravity, apply gravity. Yeah, git commit -m. Force chambers to apply their own gravity. And we'll clean up that message later. Okay. How do you balance coding and dating? That's so fun. Are those things at odds for you? That's really funny. Do you like, is it because when you talk to a girl, you're just like, fuck, all I can talk about is code? Or is it because you need to spend all day, every day coding? That's really funny. But also I just don't. And I spend all day, every day coding. So no advice from me. Anyways. Okay, let's pull. But I mean, like, you should have time to like talk to people. AI girlfriend, yeah. You can merge the two together. And you could just code a girlfriend. It's the ultimate fix. All I talk about is coding. Yeah, I get it, man. I get it. Okay. So save memory, balls memory, canvas memory. Okay, so somebody's gonna come in here and they're gonna say, hey, we have some balls to make. And we're gonna make some places to put some pixels, and we're gonna define those things here by allocating, so we're chilling there. We're gonna have some state for the pong. We haven't done anything yet. We have these functions implemented: save memory, balls memory, canvas memory, save size. All that's fine. Save load, all implemented. Step now, all we have to do is nothing. Right? And when we render, we also just have to do nothing. Wow, we're ready to go. Canvas width, canvas height, and num balls and delta. All right, so this is our chamber skeleton. So if we maybe we want to run our thing long term. So we'll run our server over here in a second window, and then here we'll just do zig build chambers. But we actually have to build this chamber, so we need to do our build.zig. We say, hey, I would like to build a new chamber, please. And it's a zig chamber, and his name is Pong, and it comes from source chambers Pong. Which means that now if I go zig build chambers, we need to rebuild our build script, which takes, funnily, longer than building the chambers. All of our chambers built. Zig out bin, we have Pong. You could make dudette chamber. Wow, you're a genius. And we can start trying to figure this thing out. So here, literally nothing's happening because there's no gravity being applied to these balls. and there is no external forces applied to these balls. So there's actually nothing to do in this chamber right now. Have you decided how you were going to accept the user submissions? Yeah, that's kind of all ready. Here, we can kind of show you. So if we kind of like go here, I submit a spinny bar thing. It gets through validation, so the server checks that it's not over like compute and memory limits. And then here I go into like this admin panel and I can like accept and reject this thing. I have a little preview of it. I go like, yep, I like this one, and then it gets stuck down here. Pretty straightforward. Pretty straightforward. Sorry. So we are working on Pong, which right now doesn't like. Okay. So this is kind of a problem. If the ball is not moving, I guess the first thing that we're going to do is we're just going to apply some impulse to the ball if it is not moving in any direction. So maybe if like the speed of the ball is like less than some number, because like the problem is that like if a ball comes into the chamber with some velocity, it's totally fine, right? Because we just don't change it. It just keeps going wherever it needs to go. But if the chamber, if it starts in our chamber, we need to kick it a little bit. So let's start there. So maybe we just like iterate over all the balls. Iterate over the balls. And we say, hey, if, I guess we look at the ball itself. Why are we iterating by index here? Is there any reason to do that? Searching for eyes, such a fucking brain dead. Okay. So we could do like balls 0 to non-balls here, and then get the ball out here like this. And we'll just say if ball velocity. Hello? It's not auto-completing because I think that the language server isn't correctly resolving this import, which kind of sucks because it's like it's not an like just adjacent.zig file. I have it like set up as a library that gets imported. So that's kind of a pain in the ass. That's okay. So we can say if the ball velocity magnitude, which we call length, which is maybe a little odd. Length squared because it's slightly cheaper to calculate. If this is less than some epsilon, we kick it. So we'll just say is like equal to some like RNG that we have. Let's give ourselves an RNG. So first, like we'll say const min velocity, we'll call it, is I don't know. 0.1 feels fast. 0.01. So these are like relative to the like size of the chamber, right? So 1 is like the width of the chamber. So maybe like 1/20th of the width of a chamber per second. Even that's really fucking slow. So maybe 0.1 is fine. And we'll call this min velocity squared because we are comparing it this way. We'll say min velocity is equal to 0.1, but we're not going to do it that way. We're going to like, I guess we're going to pick a random x and y from our random number generator and then normalize those to the minimum speed. That feels right to me. So let's give this guy like an RNG. And luckily we have like a default procedural random number generator, so we don't actually need anything to come in from the outside world. Are we not supposed to seed this with some form of thing? Because it kind of sucks that we have to use the same seed every time. That's like kind of suboptimal. But we could just use like, well, the max balls and the max chamber pixels are also going to probably be pretty consistent. And if we compile our module, then all of our like addresses of functions and stuff are also going to be consistent. So it's like everything is like pretty deterministic. So fuck it. We'll just, it's fine. It's fine. Because at the very least, I guess we could maybe seed it with like the initial ball state. Right? So like, because when we hit this reset button, like where the balls come from is going to be not consistent. So we could seed it that way. So you could do something like our RNG starts as like an optional thing and he starts as null. And then on first run, we check this thing, which kind of sucks because it means that like every physics step, you have to do this check at the beginning. But I mean, it's like, I think that one branch is not worth complaining about. So, init RNG, we'll call it. or we'll say ensure RNG initialized. Yep. Yep, that makes sense. And here we will pass in the balls array. Or we don't even have to do that because the balls array is global. So we can actually just kind of like do this like this. We can say balls, or we can say that we need to pass in the number of balls though, in which case we might as well just pass in the balls as a whole. We might as well. And we'll like make our seed something to do with all of the ball positions and velocities. So maybe we'll do like, is there like a sum in this? No. Sum? No. Okay, we can add some numbers ourselves. I just thought that there might be some sort of like sum thing in the Zig standard library. It feels like there should be. Let's just double check. Zig standard lib. Zig standard library? Fuck, I keep clicking on my fucking bookmark. Sum, not sub. Yeah, there's no, or like accumulate. Yeah, alright, that's fine. That's fine. We can write a for loop ourselves. We don't mind. For balls, ball, for each ball, first we're gonna say if RNG is not equal to null, we return. Otherwise, then we initialize this thing, which means we need self here. There's a joke in this function somewhere. If something about seeding balls, for sure, for sure. It's unfortunate the balls are generating the seed. So there's like a very, it's lining up very well actually. So what's this like RNG get seeded with? It's like equals stood rand default PRNG init with a U64. Okay, so this seed needs to be U64, and then here we just sum up everything. So it's like ball x times. So everything is going to be between like around the range of like 0 to 1. So maybe we just multiply this by like 1,000. Seems reasonable. So seed plus equals int from float. And we take the y, and we'll take the, this is position, and this is velocity. And then that should be like reasonably random, sure. Function shadows balls, that's annoying. I guess we'll just take it non balls then. Because I don't want to deal with this, so sure. Not the end of the world, not the end of the world. Okay. So then here on each step we can say self, state, ensure, hello. Oh, we don't make this state anywhere. So there, now we do. Easy fix. So here we can say ensure RNG initialize with non-balls. Yeah, cool. Cool. So now we have a random number generator to work with that we can be happy with. You think wrapping addition would ever be necessary? With a U64, fuck no, right? Like 1,000 times 100, it's like 100,000? Yeah, no way. No way. But you're right that like we might as well, huh? But I do think that it's completely unnecessary. But it's fine, it's fine. So if this is less than this, then we say state RNG random. So we can maybe pull this out here. So we'll call this random is the random interface here. And here we should be able to say random dot float. And does float give between 0 and 1? Yes. Okay. So we can just say ball velocity x is equal to this. Y is equal to this. And then we normalize this. So we say ball velocity equal to ball velocity normalized multiplied by the min velocity. Boom. That should do it. So here we can do this. These should be resolved at compile time, so it's fine. We can just store them both. There we go. That should do it. Should do it. And then I guess we're still not using the delta at all. So let's kind of fix that. But now if we build our chambers, fuck. Expected 1 arguments found 0. Really? Oh, these need to flag that they're F32s. It's kind of fun. And then cannot assign to constant. So seed here I wrote const instead of var, like a fucking dumbass. And now if we go back here and we load our pong thing, now they get kicked out. And it actually feels like that's too slow still, to be honest. So let's kind of kick them a little faster. That feels fine. That feels fine. They're all going up to the left because this goes between 0 and 1. And we probably want this to be like times 2 minus 1.0. Or we can just minus 0.5 here. There we go. There we go. Now, are they colliding with each other? Yeah, they are. Cool. Cool. Sick. Okay. Until somebody submits a chamber that really speeds them up. Oh, sure, but we limit the speed of them. We clamp the speed in the simulation. We clamp the speed here before we call into chambers. So that's a piece of information that I had in my head that you didn't, right? We clamp to 2.5. Okay. Where the fuck were we? Okay, so now we should be able to just start trying to track them with some paddles. So let's add some paddles to our state. Do we want them to be like individually named in any way? So the left paddle, his normal has to point to the right, and the right paddle, his normal has to point to the left. But other than that, they don't really have anything like particular about them. I guess they have their positions, but they're both going to be trying to track balls that are moving towards them, opposite of their normal. But we can derive which side they're on based off of the normal. Oops. I hope you guys didn't hear me burp into the fucking monitor like that, because that's gross. So I guess we probably can just directly hardcode them. Now, the benefit of storing them separately is that we only need to write down their Y positions instead of trying to store the whole thing. So let's do that, yeah. Left paddle has Y, and we'll have right paddle Y. Let's just start with one of them, actually. Fuck it. And so every physics step, we're going to try to basically move the right paddle Y to match the Y position of the closest ball. So we're gonna say something that's like find closest ball for each paddle. Find closest. So I guess also we're not gonna want to track things that have gone past us. So we're gonna have some sort of like margin. Paddle X margin. Gonna be some value. So we're gonna say like 0.1 maybe, right? Please don't clamp our balls. Yeah. Clamping and kicking balls. We are clamping them, aren't we? And we are kicking them. I have said all of these things. We are clamping, kicking, and seeding our balls. Or seeding from our balls. This is just, it's too hard not to make the jokes. It's impossible. Okay. Paddle X margin here, paddle Y here. Okay. So I guess we just find any ball that is the largest X position smaller than the 1 minus the margin. Yes. So right paddle X is going to be the paddle X margin subtracted from 1. And we're going to say for ball in balls, we look for the closest one. So var rightmost ball or right tracking ball. Yes. is just going to start at, I guess, balls 0. I think we probably also say here if numballs is less than 1, we probably want to do something separate, right? Like maybe just randomly move the paddles up and down. But maybe we just do nothing for now. So we're gonna start here at balls 0. Now we can do this without crashing. And then here we just say for balls in 1 to numballs, if the right tracking ball x is less than ball pause x, I guess both of these need to say pause. If this is less than a ball pause x, no, greater. Oh yeah, this is greater. It's greater from the other side. And ball pause x is less than the right paddle x. This is the right tracking ball. Which kind of means that this is probably supposed to be a pointer. Okay. Now that we found the thing, we just move the right paddle y, kind of just moves at some paddle velocity towards that y value. So we're just going to say that the direction is based off of the direction is going to be the ball pause y subtracted from the paddle position. Let's think about this. So if the ball pause is higher, it's the other way around. If the ball pause is higher, then we want to go up. So it's this. Okay. Right. And then this just becomes, is there like a sign of? Like in the Zig built-ins? Float. No, maybe standard library? Yeah, this sounds right. So this says if we have a float, nice. Yeah, this is exactly what I want. Nice. Noise. And so then the right paddle y is equal to the ball, or the paddle velocity, times stood math, right paddle dir. Boom. Okay. This needs a ball associated with this. This is the right tracking ball. Simple. And now we just have to render this paddle for us to see something. So I guess we also need to have like a paddle height. Well, I think the whole thing is 0.7 tall, so 0.2 feels about right. And then here we're gonna do something like, I think that I want to split out a graphics library like a little bit. Because we're kind of doing very similar actions multiple times. So let's just steal this from, is spinny bar where we have our line drawing implemented? Render line, yes. Okay, just kind of, yoink this. Now I think that render line probably should be render rectangle. But it is what it is. It is what it is. We're just going to start somewhere. Pub function render line. And this is going to take in a physics. So const physics is equal to import physics like this. Okay. Const pause 2 is a physics pause 2. This is a weird thing to be using in our graphics library, but it's fine. We can clean it up later. We can always clean it up later. So in our spinny bar, we also had 2 x picks and 2 y picks. So we'll kind of yank these out here. And then this should compile. Nope, we're still missing stood. Import stood. Okay, and then now we have line drawing capabilities, and we'll just kind of put a fix me and say like, fix me, reuse graphics, zig, and other libs. Okay. Okay. So we have our Pong chamber, and now we should just be able to do something like this thing has so much yellow. Yeah, it's kind of annoying. I think that it's partially from the language server, right? Like usually I'm used to seeing these things as white, but the language server is like marking every identifier or something, and so it turns it yellow. But you know, it's fine. It doesn't really matter. I guess it does matter because I'm streaming myself coding as a product, and if you guys don't like the way it looks, then that's bad. But oh well, you guys can suck it up. Okay, so we're gonna say that we're importing this graphic library. Okay, and now we should be able to like render a line from some start. So I guess we want to like maybe get the paddle dimensions out of this thing. So I'm really gonna say like paddle surface here comes from our state. And he's going to look at like self right paddle Y, and he's going to generate a surface, which you already have imported. Nice. And so this is going to be the right paddle surface, which means that we want to point to the left, and the surface normal is like dependent on the ordering of the points in there. So I think it's that it's like if you have this like the ground. We did it so that if this is A and this is B, the normal points up because it's the ground. Disable semantic tokens. Yeah, that would probably help for sure. So if we want the right paddle should have its normal pointing to the left, so that the physics only applies to balls that hit it from the left side. We could have it give it two normals, but fuck it. I don't think that we need it to support. I think like we don't need balls hitting it from the back. I think it's fine. Oh my god, balls hitting it from the back. It's so hard not to make the jokes, man. Fuck. This is a programming stream. I'm supposed to be mature. This fuck. So his Y position is just always gonna be right. It's gonna be right paddle Y plus. So A is the one on the bottom. So this is we're gonna do something like a const paddle vert offset is going to be the paddle height over 2. So now this is the right paddle Y minus the paddle vert offset, and its x position is just constant at right paddle 1.0 minus paddle x margin. Yep. We probably could even just hardcode right paddle x here is 1.0 minus paddle margin. I think that makes more sense. So this is just going to be right paddle x. And here we can just remove that definition. Cool. And then here we have the B is going to be right paddle x, and this is just going to be plus. Okay, now when we render this thing, we can say that we like want the right paddle surface. So this is state right paddle surface. Boom. We render a line from the right paddle surface A to right paddle surface B. Why is this not auto-completing? I don't know. But that's okay. Oh, because surfaces are defined in physics library, which isn't being resolved. That's fine. Chamber or canvas width, canvas height, and pixels. Boom. Oopsies, I deleted an important line there. Which Zig project version are you compiling this project with? Master? 0.13. 0.13 is what I'm using right now. Okay, so now when we go in here, we should have this thing. He's not moving, which is a problem. I would expect him to be tracking a ball right now, and he's just not. He also just crashed, it looks like. Index out of bounds. Yes, yeah, so this really bad. Really bad. So what the fuck is going on there? What the fuck is going on there? So the paddle height is 0.2. The vertical offset is half of that height. Okay, so that seems like it should be fine. It looks like probably the tracking is just fucking stupid, right? So the paddle Y is the paddle velocity times the right paddle dir. The paddle dir comes from our Y position. The ball Y minus our Y. We might just have to pull in some like printf debugging, which luckily we have somewhere. We have it in platforms here, so we can just kind of yoink this. So we provide from JavaScript a function to log, and we feed that in to our WebAssembly chamber, or yeah, module. So here, this like it takes in like a pointer and a length, simple, and then we just can like use Zig's utilities to just shove some shit in there, which is kind of nice, kind of nice. So here, let's just kind of print out everything here. So we have like the right ball Y and the right paddle Y and the paddle dir. Okay, let's just kind of like look at what those are. So this is these things and the right paddle dir. All right. Pong console. Pong. Attempting to access detached array buffer at WASM.js 57. Step chamber? What the fuck is going on here? I've never seen this before. Is it due to... No, even on refresh, it's still fucked. Chamber balls. Oh, I thought I've seen this before. So I think the problem is that we, during... Right. So in this function, because we allocated to print, the allocator must have moved some stuff around. We grew the WebAssembly memory, and now this chamber balls is now at like a different memory location. So we actually have to call this again. And I don't know why that's not in the code base right now, to be honest, and it's a little concerning to me because I thought I'd fucking fix this at some point. But, you know, it is how it is sometimes. So this just has to go yoinkies and then pasties like this. So this is chamber balls, and we'll just put a comment here. If realloc causes WASM memory to grow, the buffer is in a new location, and we need to look again. The fuck? Oh, that's funny. I had JS Beautify bound to the usual formatting keys, and so it's like, what the fuck? It's not there. And instead of it just like injects that shit right in line. That's really funny. It's really funny. All right. I think I have to refresh this now, and then now it should work. Okay, now we're back in the state where he is just stuck on the bottom, but we can look. Okay, so here he's saying that like the right paddle Y is at 0.1. That makes sense. Right ball Y is above it, up here, and the paddle dir is 1 here, so he should be going up. So what the fuck? You know? You know? Oh, it's because I'm supposed to write plus equals here, like a dumbass. Like a dumbass. He's still not moving? Oh, because I didn't build? You have to build the code in order to see the results that you want. You know? Okay, he's moving way too fucking fast. Okay, now we're crashing occasionally, but at least we got a lot better. So we're getting an index out of bounds in render chamber line 50. So at render, we're going out of bounds here, which is kind of confusing. Oh, it's probably this render line function. Probably if the paddle goes past the edge of the screen, we just blindly write into that index, which is fucking stupid. So we have to fix that. So here we just need to make sure that we clamp the Y value. We're probably at render line Y major, probably. And we probably just have to make sure that our Y values are clamped here. So if Y start px, we probably have to say that the Y start pixel, we can clamp it. Where do we want to clip the mouse? Right here. So that we take the maximum of the start Y and 0. And here we take the end Y pixel. I guess here we do it here. So we take the max of this in 0, and we take the minimum of this and chamber height. I think. Now, he doesn't like this because now this thing is just like a fucking weird value, which is confusing to me. This should be I64, so maybe we do like as I64 here, and that kind of fixes some of the type bullshit. Oh, not here. As I64 here. Does that fix it? No. Maybe this one? Still. What the fuck? Why? Start and so y is start ypx, which is a unknown. Do I just write I64 here? That does fix it. That's confusing. Do I need to write as I64 is here now if I hard coded it like that, or does it figure it out? It does figure it out. Oh, so maybe the max built in takes in 2 arguments and figures out which type it should be based off that. So since it knows probably that like chamber height is a U size, which is a 64-bit unsigned integer, and 2ypx is a 64-bit signed integer, it was deriving this as a U63 because it knows that the I64 maximum is like half of the U size one. It must be something along those lines. Something along those lines. He's still crashing, which sucks. I thought that would have done it. Oh, maybe we need to clamp X as well. We probably do. So here we want the maximum of this and 0. And here we want the minimum. Oh! These might be reversed order. So we actually just have to clamp them both to the height because our increment, we intentionally allow ourselves to increment both positive and negative. Right. So is there a clamp built in? No. Is there a built clamp in the standard library? Yep. So we'll do this. Stood math clamp. This from 0 to chamber height. Nice. Nice. And this is also 0 to chamber height. And then these guys get clamped as well. Boom. Yeah. And then we also do something like this. This already gets clamped though. This feels like it should have already been fine, to be honest. Yeah, it's still crashing here. So this is when we go out of bounds on X. So can we... Why are we stupid? What are we doing that's so dumb here? So Y goes to start pixel. So Y should be clamped from 0 to chamber height. So here we get the Y value here times the chamber width plus X. I guess we just we don't really have print available here, which is annoying. It's a little annoying. We can maybe pull it in somehow. Okay, well, let's just do this. Let's just set X to 0 here unconditionally, just to see if it still crashes. And that will tell us who is responsible for our bullshit. Okay, it does still crash. So it does look like Y is the culprit here. Which is confusing. So let's just do like if Y is less than 0 or Y is greater than or equal to chamber height. Oh, maybe clamp. Maybe we need to go -1 on chamber height. Should we continue probably? Nope, we need to break maybe. Still no. Wow. What the fuck? Okay, let's just try this then. If y is less than or equal to 0 or y is greater than or equal to chamber height, if x is less than 0 or x is greater than or equal to chamber width, like, surely this is it, right? Like, I don't understand. Still, how is this not allowed? How is this not allowed? Let's just make sure that we are in render y. We are. I'm lost, man. I really don't understand how we are going about. Oh, unless it's the int cast that's failing. Do we get like a nice little proper error log here? Not really. It's annoying. I guess it could be this. No, because y is above 0. Could be this. Could be this. If, so we'll call this like an I64. Say if x center is less than 0, continue, just for now. And then const, we'll call this x center I guess. X center is an int cast of x center I. No, still no. Yeah, of course not, because it's something to do with the vertical. And this is coming from render chamber. I'm actually so lost. I mean, it is this, right? Like if we go, I think we already did this, but let's just make sure that this doesn't crash. Right, of course it doesn't. Of course it does, because we're not doing anything. I'm actually like pretty lost. So chamber pixels, canvas width. I guess we should maybe we go here and we say stood debug assert, or if canvas height times canvas width is greater than chamber pixels len. We have a fucking bug. But that's not it. Not it. Okay. Let's look at this a little closer again. So we clamp from 0 to chamber height. I'm gonna -1 here. I'm not positive about this, but it shouldn't matter because we were also checking here. We're not writing anything. If I guess it should be continuous, but whatever. If y is less than 0 or y is greater than or equal to chamber height, we get rid of it. We don't fucking do it. Like, I just don't understand. Yeah, there's something really fucked here. I guess we should just double check here. If we comment this out, it should still happen. Okay. Why doesn't it compile here? Unused function parameter. Like, I'm assuming that it is related. Oh, it's not. Okay, that's a really good clue. So it's not even the canvas writing that's causing the problem. Is it possible that it's because increment is equal to 0? No. No. I wish we could debug more easily here. I wish we could debug more easily. So let's pull in, instead of just blindly guessing, maybe we pull in the printing stuff from the root module. So in Pong, we have log, wasm, and print. Can we just kind of like assume that those are available here as well? And then just start fucking printing? Call this like y, x, anchor, loop, div. It could be like a divide by 0, which would be bad. Center. We'll just kind of see where it fucking falls over. Ah, okay, so it's somewhere in these like 2ypix functions. So float from int, norm times, this could overflow, maybe? Floor offs pixels. Int from float from norm times chamber width f. Norm is the value from, oh. So our y position gets lower than 0. I see. I see. Okay. So this just gets fixed if I do this, I think. Oopsies, wrong one. Fuck, it's so easy sometimes. Okay. Fuck, that was a pain in the ass, but let's render it again. Oh, that's much better. Much better. Okay, we also want to look. We want to track the ball that is kind of like moving, kind of towards us as well. We want to fix that. So increment is math stood math sign, and then you're adding that to y. Is that correct? Yes. Because it should be 0 or 1, -1 or 1 is the value that we're trying to track there. Because we're kind of iterating pixel by pixel, if that makes sense. So we're either iterating positive, like up or down, and so we basically get -1 or 1 from that increment. Okay. So pong zig. So here we want to make sure that we're only tracking the ball if it's pointing towards us. So if right, so we'll call this like the ball. So only like balder is something like, I guess we know just based off of the x velocity. So we can do like if ball velocity x is less than 0, we continue. Now we need to apply this same thing to the first ball. So we actually want to find the first ball that is moving towards us with a velocity greater than 0. And which kind of means that like the right, we might end up tracking no balls if they're all moving to the left. So maybe we do something like a ball iter. I don't know. Right tracking ball iter or something. I don't know, man. And we're gonna say that like we have our index as well as the balls, right? And we're gonna set up like a next function, and he's gonna return a, I don't know, ball probably. And it's just like if we're gonna like basically discard anything where the x ball is not, velocity is not greater than 0. Yeah. So we're gonna look at like self, and it's like const ball is self balls self I, right? We're gonna increment I by 1, but only if we did not return 1. No, so we're gonna say if I is greater than or equal to self balls len, we're done. We're done iterating. Otherwise, we increment I after we do all this other stuff, and we say, here, return ball. Okay, chill. Chill, 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 chill. So now we can like make this iterator. Who's, I0. He starts at 0 and he's like looking at balls. I guess this is num balls because the balls is a global already, so this takes an U size. This is like num balls is num balls. Boom, bang, bang, boom. Right ball IT, nice. And then here we can just say this is right ball IT next. Boom. And then we can do here while right ball IT next. Nice. We get a ball. And we do whatever we were doing before. We don't have to do this check anymore because it's part of the iterator. And we're chilling. This we can unconditionally dereference this thing because if we got into this loop, then this was set. Otherwise, this would return null. So it's fine to like just hard dereference this here. And then we say if right tracking ball, then we move the paddle. Otherwise, the paddle stays in the same spot. Yeah. Yeah. That sounds right. Yeah. Sure. You can try it. No balls and right tracking ball iterators. This is like, it should be like this, I guess. This is greater than or equal to num balls. And this is not self balls anymore. It's just global balls. Okay. So yeah, he's only tracking the one moving towards him now, which is good. Right, he's tracking this one here, even though it's really far away. Because everyone else is moving farther away. Now he's tracking no one. Perfect, perfect. That's exactly what I wanted. That is exactly what I wanted. Hell yeah, baby. Okay, now we need to add some collision to this bad boy. So we have the ability to get the right paddle surface. So all we have to do is just look at the surface. So it's like right surface. What's up, Mickey Mick? Hey, what's up? Calling me Mickey Mick is a little weird, but I'll allow it. I'll allow it. Okay, so now we just have to say like if right, we have like right surface, and then there's like something on the surface that I think there's like ball collision, so we can look it up. Simple zig. Oh, we already have it. So we have this like loop of like we find the point where the ball collides with the surface, and then we apply that collision. I can't remember if I factored that out into some function that's like a little more specific. We have push of colliding, we have collision resolution, point within, apply ball collision, apply collision. Okay, fine, fuck it. So we get the platform normal. We just gotta do all this. So we get the platform normal. We find where on the ball it would collide with the platform, and then we apply that collision resolution, and we should probably do a push of colliding. Just like physics. Push if colliding. So this is part of surface? Yeah, I see. So this is like platform push if colliding. We give it the ball that we're working with. We have the surface velocity, which is going to be however much we moved the ball right now. The however much we move the platform. Except we can probably get away with just ignoring the surface velocity because the surface velocity is all y and our bounce is going to be entirely x. We have no friction on the ball, so it's fine. It's fine. We'll just use physics vec20 here because I don't really want to deal with it. Delta and the max push is like 0.001 or something. Who fucking cares? Yeah, okay. Delta at 84 discarded, so we can delete that discard. And let's see. So this ball should bounce off. Nice, nice. And he's not tracking anyone because they're all moving away because he caught them all, which makes sense. That does make sense. Okay, so now we can add in the left paddle because I think the right paddle's like basically there. Okay, so we're just gonna do kind of like a similar thing here. We have the left paddle Y. He starts at 0.35 as well. It's fine. Fire, you can just add your animation guy. Yeah, perfect. So here we have this like right tracking ball iterator who checks if the velocity is less than 0. I guess here we're just gonna call this like tracking ball iterator instead of right tracking ball iterator, and we're just gonna initialize it with like a like direction. Let's think about that. So this is gonna be like a, it doesn't matter, like an I32 or something. Comp time int. Maybe that makes sense. Nice. And then we can just multiply this by the direction. I'm trying to decide if that makes sense. So we multiply this by the direction, and if the direction is left, this will get multiplied by -1 and it'll invert. Yeah, okay. Yes, the right tracking one just goes 1. And so if we put in dir is equal to 1 here, this should still work, I think. Unable to resolve comp time value. It's probably confused. It's probably complaining about dir1, probably. We probably need to do something like oh, this is fine. We'll just make this like an I32 to dodge the problem. Or F32 even. It's fine. We could do it with comp time values, but I don't want to deal with it. Okay, Pong. Still looks like he's working. Still looks like he's tracking this ball, which is the most right, and he switches this one. Boom, perfect. And now we can do the same thing here, but for left ball. So all of this code is almost exactly the same, except it's just which paddle we're adjusting and which direction. So we can almost certainly factor that into a function. I don't know what that function looks like yet, but surely it's possible. So we can say like handle, like track paddle. Okay. And he's just gonna kind of do all of this stuff. All of this. Womp womp. And then we just start figuring out, so this is like the ball iterator who's going to set the direction based off of comp time int. I guess. No balls gets passed in here as well. Hello. There we go. And this just becomes ball iterator. This becomes tracking ball, ball iterator. Everything that says right just goes away. Okay. Boom, 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 boom. Okay, now we can't interact with the state paddle directly because we don't know which one it is. So we're going to say that the paddle Y comes in here as a float pointer. And now we also are going to look at the paddle X. Oh, this is a little odd. So this is checking that we're less than the paddle X. So we have to do something about this direction as well. So it's going to be, we're going to like maybe say the paddle X, this paddle X, tracking paddle X, is equal to if dir is greater than 0, i.e. we're moving to the right, then it's going to be right paddle X, else it's going to be left paddle X. That seems fine to me. Which means that we need left paddle X to exist. Okay. Now we can use the tracking paddle X here. And we also have to multiply this by direction as well. I guess. And if the tracking ball position, can we do this just multiplied by dir as well? I'm not 100% sure on these, but I feel like they will work. Maybe. But we'll find out. We will find out. Unused function parameter, which one? Numballs. This is in there. Paddle Y. Ah, here. Okay, so this is like this, and this is like this. Okay. So that might work. Might work. So we can do like track paddle 1 with the number of balls and the state right paddle Y. Okay. So if this works, nothing should change. So he's tracking this one, moves down here, switches to this guy. Yep, switches, boom. Okay, everything's good there. Let's try to add the left one now. So this is just going to switch to -1 and look at left paddle Y, and we also have to draw the left paddle. So that's going to be in our like render function somewhere. So here we're just going to have to get the left paddle surface as well. And this is just going to be the same thing, except using left paddle X. And left paddle Y. Boom. Boom, boom, boom. Okay. Simple. We didn't draw it though, which makes it really hard to deal with. So left, 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 left. All right. Looks like it's not tracking the right ball. It's tracking like the one that's farthest back or something instead. So that like direction switch here did not do what I thought it was going to do. Okay, so it needs to be, depending on the direction, we need to basically change this. Like I was trying to invert this condition, which unfortunately did not work. So if the tracking ball X, this one we need to be like it's greater than if we're going left, which maybe just means that this is like can't be super duper generic. Okay, let's look at what is this thing doing. So if the tracking ball X is less than the ball position X, i.e. the ball is closer to the paddle, this is ball closer to the paddle, and the ball is moving towards the paddle. Right, right. So if the ball is moving to the right, no, the ball is to the left of the paddle. So if we want the ball to be to the right of the paddle, like we just need to invert these conditions for the left paddle, I'm pretty sure. Like if we do this and we load this again, the left paddle will track the correct ball and the right paddle will not. So can we have this condition work for both? Maybe not. I mean, we could do something like check closest ball or something. Could do it based off distance. Yeah, I see something there. There's definitely something there. So we have the tracking paddle X. So you could do like tracking paddle X minus something. Yeah, so we could do like a const dist is the tracking paddle X minus the, so we'll call this track current dist is the tracking paddle X minus the tracking ball pause X, and then the new distance is the same as the ball with the ball. And then here we want to say if the new distance is closer, current distance, and then we probably also want to like absolute value these. No, we want to make sure that they're on the same side. So here, when we are moving to the left, right? So when we're like this guy, the ball is coming this way. right? We have like our position is 0.1, this is 0.2. So we're doing tracking paddle X minus tracking ball X, and then we want like 0.3 to lose to 0.2. But we want 0.05 to lose to everything. This guy isn't even considered. Right? So this guy gets us started if it's a positive number. But when we have it on the right side, we have 0.9, 0.95. All of a sudden it's like inverted. So maybe it's like if this can probably be multiplied by the direction. Probably. There's something like is past is going to be like it's going to be the new distance times negative dir, I think, or times dir. So here these are -1. So tracking paddle minus this position is going to be positive, but then we're going to multiply this by the direction of travel, which is negative. So this can become negative again. So if this is less than 0, it's probably what I want. So we're going to want like is past. If it's not past, so we just invert this condition. That's fine. If it's not past and the new distance is smaller, and we absolute value these. And that seems like it might work. I'm not like, I'm like maybe like 25% that I got that right. But this right one is tracking correctly, and the left one looks to me like it's tracking correctly. Yeah, he jumps down to this. Yeah. It looks right to me. Yeah. Okay. I'm okay with that. Looks about right. Okay. I like the idea of instead of like being sure that it's right mathematically, we just stare at it for a while. We're like, fuck it, yeah, sure. Why not? Okay, so here we're gonna have to iterate over the left and right surface. So here we're gonna be like platforms is going to be two surfaces, one of which is the right paddle, and one of which is the left paddle. Simple. Now we go for platforms. We have a platform. And kind of swings out like this. And now, does it work? These are not bouncing at all. So clearly not. The right ones are still bouncing off. Why are the left ones not? Is the left paddle surface pointing the wrong way? We need A on top. Yeah, this is pointing the wrong way. Pointing the wrong way. Much better. That's kind of fun. Now, there's a problem here where, yeah, balls are making it through. So I think this is maybe okay. Okay, so we need to implement like save and load so that the physics matches the what's it called? The rendering. Which just kind of means that like we need to make sure that this view like tells us if we fuck that up. So I kind of want to implement like a client, like in the chamber test. I kind of want to like in here maybe add like a little check mark that says like, do we want to test the save and load flow? And if we do, then we're gonna reset the chamber state between physics and rendering. So let's kind of say like down here, we'll say label for test save load. We'll say this is a test save load logic. Seems fine. And if this is true, then we will have this as ID save load. And this is going to be like a type is checkbox. Nice. Okay. Sure. I'll take it. Oopsies. So if we refresh this now, we have a test save load. What the fuck? Okay. We'll fucking stick this in a div, I guess. Okay. That's better. I guess. I mean, it looks like shit, but whatever. Then we need to make it so that in our JavaScript, we somehow do something with that thing. So it's going to make it into this like local simulation thing. And here, he on every frame steps the simulation. And here we just need to make sure that we go like chamber load and chamber save. Maybe use label tag for the checkbox. Did I not? Is this not label? I'm saying label for this thing. What's like label tag? Is this not a label tag? Am I fucking stupid? I'm happy to be told that I'm fucking stupid. But is this not using, I'm labeling, I have a label and I'm saying it's for this. Is this not correct? Oh, you missed it. Okay, no worries, no worries. No worries. Okay, so what's kind of confusing here is we need to make sure that like the entire state of the chamber gets like kind of like reset between these two things. So it's almost like we want two simulations. One for rendering and one for physics. Hold on, let's see. How do we do this when we have like a server-side simulation? I think that comes here. So here we like load chamber with the chamber state. And this basically says like, hey, I have like some like data. I'm gonna like shove that data over here and type load. Yep. Okay. So I guess we just want a different simulation here, I think. So I think if we want like a save load tester, I think it's just gonna look very slightly different. So he's gonna have two chambers inside. He's gonna have like a like physics chamber. And he's gonna have a render chamber. Yeah. He's gonna attach the physics chamber to the simulation. So wherever you use this, he's gonna say, hey. Oh, it's not even, this is not done here, I guess. Because it's already initialized, I guess. So here we have somewhere in like chamber tester. He creates this local simulation probably after he makes the simulation. So he says simulation, I create this thing with make simulation with the chamber. Ah, okay. So make a simulation, we give it a chamber. So we're gonna make the simulation with the physics chamber. Then we have a simulation here. We're chilling. We make a renderer from it. Also fine. And here we're gonna use the pixel data is from the render chamber. Yes, from the render chamber. Then down here, we step the simulation and then we say, hey, let's get the physics chamber, load its state, or I guess save. Yes. Yes. And then we're going to say render chamber load. And all we have to do now is like figure out the like how to copy paste the data between these guys. So we're gonna say like we have like the save memory from the physics chamber. Oopsies. And we're gonna like turn this into a U and data array somehow. So it's like this. So it's gonna be the physics pointer is we take the save memory and save length, I think. I don't remember what it's called. We're gonna have to look. We'll look at spinny bar. So he has a save memory, save size, and save. So this is the I guess we can just slap these here like this. Okay. This is the physics save, and then we can get the render save as well, like this. Yup. And then we just say render save set physics save, I think. And that should copy the data over. So we save the physics chamber, we get the data from that, then we get the render thing, we put the same data over there, and we load back. And then we load with the render chamber. We render with the render chamber. Like, might work. So this we're gonna call not local simulation, but this is gonna be like a split local simulation. Okay, and then in chamber test, I guess we'll just say that when this thing changes, we basically reload this thing using that new value. So we're gonna have split sum to a function that's like load chamber. Okay. And he's basically just gonna do this stuff. Everything in this. So here, instead of using the event to get the files, we're gonna pull it from. I think we can just pull it from the like HTML element. I think. So wasm input. So can we just do like, const file input is document get element by ID wasm input, and then here we use file input files. Maybe. I don't think there's any like required variables here. Oh, num ball spinner, speed slider. Okay, so these guys all need to. Can we just put them in global space? Doesn't fucking matter. Speed slider. Like, why not? Why not? And then on init, we just assign these to the global variables. Okay. Then on change, just load chamber like this. So we can just delete everything in here. And let's just see if that works first. Because if this works, then we're on the right track. Yeah, that works fine still. Cool. So now we just have to make it so that we call this same function on the change of the save load logic. So we're going to say like const save load logic is equal to checkmark is equal to document get element by ID. And this is like, what the fuck we called this thing? Save load. We're going to give him the same event listener. Okay, so let's see. Wait, if I go here and I upload Pong and I click this, it does look like it's kind of resetting the simulation, which is what I wanted. Yep. Okay. And now I just need to make sure that, like, instead of making a local simulation here, we're gonna say if. I guess we're gonna make this a global variable too, because I don't want to deal with it. Yep. So then we can say if load checkmark value is equal to true, we create this thing. No, this is on false. Okay, so let's just start by doing nothing here. And so we can load Pong, and when we turn this thing on, it is still making this on both. So this is not working the way I expect. So let's console log this. Maybe I just don't understand the type. Why does it say on no matter what? Oh, it's checked. Thank you. Of course it is. Nice, nice. Thank you, thank you. Big win. So this is just gonna be, instead of local simulation, it's like split local simulation. Which means that here we need to import split local simulation like this, and we refresh. Hit pong. Here he doesn't like, okay, so now we're getting into trouble here because the split local simulation needs 2 chambers. So it's kind of like, here we just need to make a second chamber again, I guess. And this is going to be the render chamber. And then we put render chamber here. I think that was all we had to do. No, he doesn't like this. Okay, let's turn this off and try loading again. So even this is not working now. I fucked it up to the point where this is just not doing what I expect ever. Let's comment out this just to make sure that, like, this simulation is undefined. I don't really understand here. Hold on. Thinking. So, oh, oops. I just fucked up the order. This should be like this. Oopsies. All right. Refresh. Load. So here we have something, and then on the split one, it's fucking broken. But that's okay. So simulation is not defined. So split local simulation. This is happening at 75. Right. That makes sense. Simulation is undefined. They're correct. What's he complaining about now? Index out of bounds. Here at chamber instance exports render. Because he's trying to use... Can we fucking pause on exceptions? Pause and cause exceptions? Okay, why the fuck is he not pausing then? Are these not exceptions? Am I high? Oh, now it's fucking doing it. Okay. Index out of bounds. Oh, because we didn't initialize the new chamber, maybe? Yeah, we probably just didn't initialize the chambers. We have to do like render chamber exports. Instance exports init with the do we not call init here? No, okay. So we're gonna initialize it with 0 max balls, but a... Where does like chamber canvas width come from? Oh, here, canvas width. Let's do this. Well, okay. Sure. I don't fucking know, man. I don't know, but maybe. Yep, okay, cool. Cool, that's really good. So when we turn off test save load logic, it's like tracking correctly, and we turn this on, then nothing fucking happens because the render side of the chamber is not getting the updated state. So you can see that the balls are actually still bouncing around, but we're just not rendering the platform state correctly. So that's really good. That's already like a major improvement in like how we use this thing. So we can go back into the chamber, the pong chamber, and here we just have to implement save and load. So save and load are pretty straightforward. We just have to take the state from this thing that we care about and make sure that it makes it on the wire. So technically the RNG state doesn't have to be updated. which is kind of, oh, but we do save and load. Do we start to save and load on the server ever? Maybe not. So we might be able to get away with just saving and loading the paddle. Although that might be like bad practice. But fuck it. Fuck it, you know. So save memory, we're going to return. I guess we need to allocate some save memory. So we're going to say that the save size is 8 bytes. We're going to allocate that area on initialization. So we'll say like var save here is maybe a pointer of 2 floats, to be honest. That feels good to me, so we don't have to allocate anything. This is going to be the studmem byte. As bytes, maybe, of save len. Nice. Save memory is just going to return save pointer. And we can do a little tricky here and return this. Instead of returning it with this, we can return it as a pointer to F32s. And that kind of just makes it easier to deal with, so we don't have to pointer cast. This save is just going to say, oh, fuck. This needs to be called save data, because we're name colliding. Okay. Save data, 0 is equal to state, right paddle I. 1 is left. Maybe we swap them. I like left being on the left, and I read left to right. And then we just do it the other way. Equals save data 0, save data 1. Okay, so now we can, oops, he doesn't like this. I guess it's like this. Really? Really? Oh, this has to be like this, I guess. Fine. Fucking Zig trying to be all nice and check my types for me. What an asshole, that guy. I hate him. He doesn't like this because probably we had to put an ampersand when we did as bytes, maybe. Oh, slices bytes is what I wanted. Probably. Okay, refresh, pong. So clearly I fucked this up in some way. What the fuck did I do wrong? So there's many places this could have gone wrong. I could have fucked up the actual serialization and deserialization. So we can test this on something that we know should work. And it's the JavaScript side. So let's go back to chamber test. Here we're using a split local simulation, and it's probably just something in here. Let's just maybe console log physics save, console log render save, and let's just see if those line up at all. Does the save data not match the logic anymore? Did we swap the values? I could have made a mistake in there. Okay, so here, so we're not even like just looking at like spinny bar. The fact that this is giving me a constant 4-byte value all the time is really concerning to me. Because we're using the simulation memory for both these instead of the fucking memory associated with the chamber. That would really do it, huh? Trying to load the memory from a pointer from one memory into another pointer. Okay, so now spinny bar is working, which is great. And does pong work? Pong is also working, which is good. Nice. So both when we're just rendering the chamber directly and when we're using save load logic. Sick. Okay, so now we've gone through the flow of building our module and testing it here. Now we can see, okay, what happens if we upload the module? So we'll say, hey, we are uploading our Pong module, please. And we submit. We go here and we see that we have a validated Pong module. We can go to our admin thing. We can like say, okay, I accept this. And we go to the simulation. And there are no balls in the Pong thing, which kind of makes it hard. But it does look like, ooh, So this is kind of interesting, in that we kind of like found a problem just like by mistake. In that like, well, I don't know if it's a problem, but the fact that like we don't have like bumpers on the left and right. Actually, maybe that's fine. Maybe that's fine. That kind of looks kind of nice, to be honest. Right, like one getting stuck in there is like kind of fun. We need to up the elasticity of the. I mean, it's fine. We lose some velocity every time the ball hits the paddle. But then we might like kick the velocity back up if we have to. So that's actually pretty slick. That's actually pretty cool. Oh, you really caught that one. Yeah, that's pretty fun. That's pretty fun. Okay. Yeah, that's sick. Okay. That took longer than I thought it would. It's 3:45, so we've been at this for an hour 45, and so I think I'm gonna call it there. We still need to get like the Pac-Man one up and running, so I'll probably just do another chamber tomorrow, where tomorrow we'll work on trying to make it. Fuck, ad break. Oh, that's a really unfortunate timing for that. Sorry, guys. But yeah, tomorrow we'll try to make it so that the Pac-Man version works okay. Oh, it's pretty funny too. Actually, you can see that the paddle from below is sometimes knocking balls into the chamber above it, and since this surface doesn't bounce things back down, then it actually like makes these balls like jump all over the place. That's really funny. That's pretty funny. Okay. Yeah, well, I think we'll do like we'll try to do a chamber tomorrow that requires some sort of like front buffer. Gonna stick up the hosting for us to do some testing. No pressure. I'm on holiday next week. Totally selfish. Yeah. I mean, I'm going to go. I just want to get the front buffer in. So this is up. Feel free to start if you want to try it. Like you can. But I think I think it's very likely that I'm going to add one more API. So, I'll push what we have right now to the work in progress branch, but like it just kind of sucks because like the physics library isn't like 100% there yet. Like we made changes to the physics library like today, right, that aren't going to be in quite yet. So I'll push them to the work in progress branch, and you can like go here and try it if you want. Oh, except this version of the fucking thing has gravity applied. So maybe wait till tomorrow. Well, I'll make sure that it's up with the latest and greatest by tomorrow, and then you can play with it if you want. I won't have instructions up yet. I would need to write like an instructions page on here somewhere. But if you're just like want to play around with it, like yeah, fuck it. Like if you submit a chamber and it works, I'll take it. Right? Like, okay. Yeah, I think we'll call it there. So thanks for watching, guys. If you like what you saw, we stream most days at around 2:00 Pacific time for around 2 hours. That's the main stream. We also do this like pre-stream thing where you'll notice that we left a lot of stuff in like not really the best state today. And so the pre-stream starts at like 12:30, and that's only on Twitch and Patreon. But what we do there is kind of like make sure that anything that we worked on that's not in like literally good state, we kind of like clean that stuff up. Kind of like the more boring, less focused work. So if you want to check that though, that's available. Let's see what else. If you're new and on Twitch, there's a YouTube link in the Twitch description. Where you have stuff organized into playlists per project. Right now we're working on this collaborative Rube Goldberg machine, but other stuff that had been done in the past if you want to check that out. GitHub link in the Twitch description where code for this will go up. And what else? I think that's it. Thanks for watching, guys. YouTube, let's say goodbye, and Twitch, let's find someone to raid.